I am Kenneth Jan L. Milan from BSED Math 1A, and today we will tackle about these 5 topics: resets, real number system, exponents and polynomials, equations, and inequalities. So first, let's talk about sets. What is sets? So sets is a group or collection of objects, and it is named using a capital letter. For example, the set of all numbers below 6. So 1, 2, 3, 4, 5. So these numbers is called the elements. So the symbol for these elements is this. So there are two kinds of sets, the null set and the well-defined set. So let us first know what is the null set. So set A, if we delete this one, this is what we call a null set. So a null set has no elements. So it is denoted by a sign like this. Second one is the well-defined set. So a well-defined set has a minimum of 1 element. So this is what we call a well-defined set. So next is the subsets. So what is subset? So if we put some elements here, 1, 2, 3, 4, 5, then the set B would be like that. So as you can see, the elements of the set B can be seen in the element of the set A. So this is what we call subsets. The element here can be seen here. So next is the cardinality. So what is cardinality? So as you can see here, there are 5 elements, and here there are 3 elements. So as if we count that, so the number of cardinality for the set A is equal to 5. Then the number of elements inside letter B is 3. So that is their cardinality. So that would end our topic sets. So on to our next topic is the real number system. So real number system is composed of rational numbers and the irrational. Then the rational numbers contains integers, the whole numbers, and the natural numbers. So first, what is the natural numbers? So natural numbers are any counting numbers. Example, 1, 2, 3, 4. Next is the whole numbers, any counting numbers, and also included is the 0. Then 1, 2, 3, 4. That is a whole numbers. Then these integers are those numbers that are these numbers and its opposite. So meaning they're negatives. So these numbers, negative 4, negative 3, negative 2, negative 1, then 0, 1, 2, and 3. So that is the integers. Next is all of these numbers are included in the rational numbers. So why does it belong in the rational numbers? So rational numbers are any number that can be written as fraction. Example is this 2. Then we turn it to fraction is 2 over 1, then 3 over 1. These are examples of rational numbers, and also these are the sum. If we put that any point, as long as it has an end, it is what we call rational. So numbers. Next is the irrational number. So delete it first, then irrational numbers. So any number that is not considered a rational number is what we call irrational numbers. Then examples of these numbers are square root of 2. So the square root of this number is non-terminating, or example is like that, 2.111 or 2.123 that has unending numbers. That is what we call irrational numbers. So the next topic would be exponents and polynomials. So first we will define what is a polynomial. It's just an algebraic expression with several terms. Usually polynomials have more than one term and numbers. So a polynomial consists of monomial, binomial, and binomial. So first, what is a monomial expression? So we write a 3x cubed. So this is an example of monomial expression that consists only one term. Then next is the binomial. We write 5x minus 3. So as you can see, there is two terms, the 5x and the 3. So this is what we call the binomial expression. Next is the trinomial. As you can see, there are three terms, the 2x squared, the negative 2x, and the 1. The 2x, and then 1. So there are three terms. So that is an example of a trinomial expressions. Now we would solve some polynomial expressions. So example is 5x cubed plus 2x squared minus x squared plus 3 minus. So as you can see, there are 1, 2, 3, 4, 5. So there are 5 terms, but there are some terms that are similar, that has similar variables and exponents. So we must combine them. So next is 5x cubed. There is no similar term, 5x cubed, plus next is the x squared. So as you can see, they have the same term. So positive 2 minus 1, then copy the expression, the variable and the exponent. So 2 minus 1 is x squared. So we could write x squared because there could be the imaginary 1 beside the x. Next is the positive 3 and negative 8. So if we minus that, we could get a difference of negative 5. So this would be the result of these terms. So the process that we use is what we call the combining like terms. That's all for polynomials. So the next topic would be the exponents. What is exponents? It's a number or letter written above and to the right of a mathematical expression called the base. It indicates that the base is to be raised to a certain power. So I will give you some example to understand more about exponents. So an example is that 3 raised to the power of 2. It means that this is the base, the 3, and this is the exponent. So it means that the 3 should be raised to the power of 2. So 3 times 3. So this would be 9. Next is that we will perform the adding, subtracting, multiplying, and dividing exponents. So let us first the addition and subtraction. So we have a given example of 3x squared x cubed plus 2x cubed. So as you can see, they have the same variable and exponent. So in addition and subtraction, the variable and the exponent must have the same value so that you can add or subtract a given algebraic expression. So as we solve this, 3 plus 2 is equal to 5, and then copy the variable and the exponent. Then if we will divide, make that minus 3x cubed minus 2x cubed is that, again, copy the variable x cubed, then subtract the base or the coefficient. So 1x cubed, or we can write that as x cubed. So next is the multiplication. Multiplication, like 5x squared times 2x cubed. So as you can see, again, the base and the variable, then the exponent. Then we will multiply the base, so 5 times 2 equal to 10, then copy the variable, then add the exponents, 2 plus 3. So the answer would be 10 to the power of 10x to the power of 5. Then the last mathematical expression would be the division. Divide 6x cubed divided by 2x squared. So this is the dividend, this is the divisor. So copy the coefficient, 6 over 2, then copy the variable, then subtract the exponents, 3 minus 2 is equal to 6 over 2. So in this lowest term, 3, copy the variable x, then 3 minus 2, 1, so we have 1, so you can write it as x. This would be the final answer. Then we will move on to these two cases, 0 as an exponent and then the negative as an exponent. So in this case, first the 0 as an exponent, so we would write 6 to the power of 0. So as you can see, if any number raised to the power of 0 would be equal to 1. It is always equal to 1, any number, even if 1 million raised to the power of 0, it should be equal to 1. Then the second case is the negative as an exponent. We'll write 4 to the power of negative 2. So in this case, we will perform the reciprocal method. So we have imaginary 1 here. So in this reciprocal, so 1 over 4. Then we will remove the negative since we get his reciprocal. So 4 raised to the power of 2. So that is the negative as an exponent, and that would end our topic on in exponents. So the fourth topic would be the equation. So it can be defined as a mathematical statement consisting of an equal symbol between two algebraic expressions that have the same value. So we will have some examples here. Minus 12 is equal to 0. Again, equal sign. Then we will perform the addition property of equality. So add both sides by 12. Add both sides by 12. We come up with 6x, since we will terminate this equal to 0 plus 12, then 12. Then in this case, we will find the value of our x. So divide both sides by 6. Divide both sides by 6. Cancel. Then x is equal to 12 divided 6 is 2. So our value of x is equal to 2. Then we will check the equation if it is a true statement or false. Then 6x minus 12 equal to 0. So our value of x is 2. So 6 times 2 minus 12 is equal to 0. So 6 times 2 is 12 minus 12 equal to 0. So 0 is equal to 0. So the statement is true if the value of x is 2. So on to our last topic, the inequalities. So inequalities is a relation which makes a non-equal comparison between two numbers or other mathematical expressions. So there are 4 inequalities. So these are the symbols: the less than, the greater than, the less than, the greater than or equal to, and then the last one would be the less than or equal to. Then we will solve some examples here to show, understand more about this topic. So we have here 12x minus 14 is less than 10. So again, we will perform the 12 intermediate here, plus 14, add 14 by both sides, plus 14, then we come up with 12x is less than 10 plus 14 or 24. Then we'll find the value of x, divide both sides by 12, cancel, x is less than 12. So I will show you the interval notation for this statement. So interval notation would be negative, since we are dealing with an inequality less than, so these are the interval notation, negative infinity, then the value of our b would be the 12. So any number less than 12 or the negative infinity. So then this is the interval notation. Then I will show you the set builder notation. So the set builder notation for this problem is x such that x is less than 12. So this is the set builder notation for this problem. Then if I will show you with the number line, so the value of our a is negative infinity, then the value of our b is equal to 12. Show you the number line here, here. So this is the value of our b, the 12. So this is the value, so this is the value of a, negative infinity. So any number belonging here, negative infinity, any number belonging here, like 11 or 10, 9, 8, until negative infinity. So this is the number line that shows the value of our a and the value of our b. So in this video, the 5 topics has been tackled. Then on to our next video. So thank you for watching. Once again, I am Kenneth John L. Milan from BSN Math.